Hi everybody. Welcome to lesson 9.3b. We're going to talk about vertex form of a quadratic. And we kind of talked about this already when we talked about 9.3a and we talked about the different transformations. We can translate left, right, up or down. We can reflect over the x-axis. We don't really worry about the y. Or we can do a dilation where we stretch or shrink vertically. Or it's narrower or wider than the parent graph. So what we're going to do is we're going to turn quadratics from our standard form, which everybody knows, ax squared plus bx plus c, and we're going to turn this into vertex form of a quadratic. Y is equal to a multiplied by the difference of x minus h, quantity squared, plus k. And remember, we talked about these things in 9.3a. We talked about the a, both what the sign, positive or negative, and then the absolute value of the number itself tells you about the graph. We talked about what the h does and what the k does. So let's go into a quick thing here. So it's hard to read, I know, but here's my vertex form. And we're actually going to make these equations from standard into vertex form. So notice up here, we know that the h value is a horizontal translation. So if you've got a positive h value, it goes to the right. If you've got a negative h value, it goes to the left. We've got ourselves a vertical translation. K at the end, when you add a number at the end outside of the parentheses. If it's positive, you go up. If it's negative, you go down. For the h, I forgot to mention, you might want to give yourself a little reminder. The h is the one that's inside the parentheses. You just have to watch that sign because it's an x minus h, so you have to leave a negative behind when you figure out what the h is. The a value allows you to do a reflection. Remember, we just talked about when it's positive or negative a value. If a is greater than 0, it opens up. You've got a minimum value. If it's less than 0, it opens down. You've got a maximum value. And last but not least, our dilation. You just look at the a value, not the sign. The graph is stretched vertically if it's greater than 1. Vertically means that it is narrower than the parent graph. If a is a fraction, or decimal, when we're just looking at the absolute value of it, it's compressed vertically. I always think of compressed, if I sit on it, it's going to get squished. It's going to be wider than the parent graph. So our a value tells you about the dilation and the max or the min. Max or the min reflects back to, remember, if it's a reflection. H and K is an interesting one because that becomes our vertex. If we take the vertex of the parent graph and we translate it 2 units to the left and 3 units down, that's still the vertex. So wherever you slide that thing around is where your vertex lands. So in vertex form, H and K are your vertex. And again, just watch carefully for that H value. We also know that if you just take the H value, that's your axis of symmetry. That's what you would have gotten if you did negative b over 2a, because everybody knows that formula, right? C from your standard form equation is still, I'm going to make a note here. That's from standard form. There is no C, notice, in vertex form. So that's still your y-intercept. So if you start off with the standard form, you've already got your C value. And the domain is all the values you can choose to put in for x. So basically, we're allowed to put in any real number for the x value. The range, however, you're going to have to look at your graph or your table. And if I'm going to use this guy right here as an example, I could say for my range, it's all values of y such that my y values are greater than 0. Notice this is as low as it gets. Everything else is up above that. If my parabola is open down, It would be all values of y such that y is less than 0 or -1 or whatever it might be. So if you can get it into vertex form, you have got a ton of information there. And we can use that. We can use it to graph. We can use it to analyze different parts. So let's talk about how you can turn a standard form equation into vertex form. So to start with, know what your A, B, and C are. We've done this 100 times, right? You need to know what A, B, and C are. Next, I know it seems weird, but scooch C over. By scooch, I mean give it some space over off farther to the right, and put parentheses around the first half of the problem. What I mean first half of the problem, I mean I'm going to do this. I'm going to scooch C way over there, and I'm going to put some parentheses with some room in it. That room inside the parentheses, and scooch is a real word, by the way, is where you're going to add a value. So we're going to need to put something right in here. So this third bullet says to find half of your b value and square it. So what if your b value was 10? What's half of 10? Now square that number. Are you telling me it's 25? What if your b value is 14? So find half of 14, square that number. Hopefully you're telling me the answer to that would be 49. What if your b value is 2? Find half of 2, square it. Everybody's telling me that's a 1, right? So it's really nice and convenient when it is an even number. What if your b value is 1? What's half of 1? Everybody's agreeing it's 1/2. What about when you square a half? You could probably go to your calculator. You could put in a 0.5 or you could put in a fraction 1/2, but either way it goes, you're going to get a 1/4 or 0.25. We can still do that. We can still use that. It's just not as nice. You're going to take that value and add it inside the parentheses and subtract it outside the parentheses. So I made a little highlight spot for that inside that parentheses. And I'm always going to add it here and subtract it outside. If I give you 5 pieces of candy and then take them away, do you have any candy? You did not have a chance to eat it before I took it away. So what we're doing is we're adding a value and we're subtracting it, but we're not really changing anything. Then this is the tricky part. This is actually a factoring shortcut right here. I am telling you how this will work. If you trust me, you can save yourself the factoring step. You're going to write the trinomial as a perfect square binomial. And then we're going to do that math on the outside where we've got the c and then some other number. So let's talk about this. Let me move this up a bit. I wanted to have my steps here so that we could look at this. So example 1, I've got, write y equals x squared minus 10x minus 8 in vertex form. This is in standard form. My a, b, and c, I'm going to say my a is 1. What's my b value? And c value. You don't have to write that. I just like to be able to identify it. That way we know what's here. So if I write this in vertex form, the first thing I'm going to do after I identify a, b, and c is I'm going to scooch c over. And I'm going to put parentheses around that first half. Now next I'm going to find half of b, and I'm going to square that value. What's my b value? -10, right? So -10 divided by 2 is, square that value. Please be careful on the sign. Add that value inside. Everybody agrees with the 25, right? Because -5 times -5. And then I'm going to subtract it outside. If I give you 25 Tootsie Pops and then I take 25 Tootsie Pops away, you've got exactly what you started with. The last step, I didn't put a lot of words there. I just said write the trinomial as a perfect square binomial, but we've done the hardest part of the work so far. So what we're going to do is we're going to still say y equals. we're still going to say a set of parentheses, except we're going to move the square to the outside. Really what we're doing is we're factoring this. I should put that on the other side. Really what we're doing, there we go, is we're factoring. But I'm telling you that this is a perfect square trinomial, and we can take a little shortcut. So take the square root, or take your variable, put that there, and then in this part right here, this is your half of b value. What was our half of b value? -5. If you want to go over to the side, hit pause now and factor x squared minus 10x plus 25. Ignore the stuff on the outside of the parentheses. Make a square, make a product sum table. You will get x minus 5 and x minus 5. So really what you're doing is factoring, but I'm showing you a super fast shortcut that works. Because we took the half of b and squared it, we made it so we don't have to do the factoring because we did it right. Last but not least, I've got myself a math problem out here. -8 minus 25. I've got myself a -33. So this is vertex form. I'm going to highlight it. Here's my answer for vertex form. It's actually not as bad as it looks once you get the hang of it. Scooch, take half of b, square it, add it inside, subtract it outside, and then that little factoring shortcut. So now, looking back at that table that we did right at the beginning, I kept axis of symmetry first, but really, we could do the vertex first. So here's our equation for vertex form. I like to start with vertex for vertex form. So vertex is always going to be h and k. So be careful on the sign for the h. What's my vertex for this problem? I'm going to say +5 and -33. So check the sign on that one inside the parentheses, and then take your number out on the end. Basically what that says is that shifts our graph right 5 and down 33, so that's where our vertex had to land. We mentioned in the table that was up above, our axis of symmetry then will always be x equals our h value. We know that this graph opens in a direction. Does it open up or down? Based on our a value. A is either the number right here that we identified from our original equation, or it's the number that's out in the front. If there isn't one, we know it's a 1, right? +1. So that graph opens up because it's positive, which means we have got ourselves a minimum value. Y-intercept is always our c value from our original equation, which means it's going to be -8. Big hint, domain. We're allowed to pick any values that we want for x. It doesn't matter. We could put any values into x in this equation, or we could put any values in for x in the vertex form equation. The range, however, is interesting. So let's do a quick little visual here so you could see it. If I drew myself a graph and I said that my vertex was going to be at over 5, down 33, way down here. We said that this parabola is opening up, so it's a minimum. Look at the y-axis. Remember, the y-axis is always this one. All of our y values, looks to me, go from our minimum on up. So all of our y values are greater than or equal to -33. All y values such that y is greater than or equal to -33. It could be -33 because that's our vertex. And I should put that in swirly brackets, set notation. Range is the hardest thing out of all of these guys to get. So let's do one more, just to make sure, and then I'm going to leave one for you to do. Let's do number 3, because it does have an odd b value. So I'm going to do exactly the same thing. I'm going to start by identifying a, b, and c. This one could be a trick question. What's my A value? B value? And C? Aha, there isn't one. You could put a +0 on there. So now remember, I'm going to scooch, and I'm going to leave room inside those parentheses. You can write the +0 if you want. You don't have to. So now, in order to know what to put, add inside and subtract outside, I need to take half of b and square it. So half of 15, I'm going to do 15 divided by 2 instead. 7.5, square that. So what is half of 17.5 squared? I'm going to just go to a decimal, double check me, but I think it's 56.25. I'm going to add it inside and subtract it outside. Because remember, then it doesn't change anything. Now this looks like a mess, right? I'm ready to go to a set of parentheses with the squared, and this is a factoring shortcut. That's all we're going to do is factor this. But there's an easy way to do this. We put our variable first, x. We put our half of b second, half of b. What was our half of b value? And was that 7.5 positive or negative? So that math is done. So then this is just a math problem to do right here. What's 0 minus 56.25? And we have got ourselves vertex form. Once you kind of get the steps, it's not as bad as it seems like it could be. So first of all, what's our vertex, our h and our k? H looks to me like a 7.5, but it's got to be negative, right? This is my h value. Watch the sign. So negative 7.5, comma, negative 56.25. It's not a very nice vertex, but we know what it is. What is the axis of symmetry? Remember how when we were doing negative b over 2a, we'd do that first and then we'd reuse that? Well, now we're finding the vertex first and we're reusing for the axis of symmetry. Is this parabola open up or down? In other words, will that vertex at negative 7.5 and negative 56.25 be a max or a min? What is the y-intercept from our original equation? C was 0, right? So it's got to be 0. What is our domain? Note to self, always going to be all reals. And our range. I'm not going to draw this one. I'm going to ask you it the same way as the last one, though. If you picture a vertex at back 7.5 and down 56.25 that opens up, what are all of your y values up and down? We've got a lowest y value and everything else must be greater than it. So it's going to be all values of y such that, would you agree that all of our y values have to be greater than or equal to negative 56.25? Sketch out that graph if you need to see it. They should all be at 56.25 or above. There is no y value we will never count lower than negative 56.25. All right, so lesson summary. Here's just one to kind of refresh your memory. How do you know what values you're going to add inside and subtract outside the parentheses when you're going to vertex form? How do you know what to put there? What math problem or problems do you have to do? And I would like you to turn this equation into vertex form. Notice I gave you a b value with an even number, so that's really nice. So y equals x squared minus 2x plus 1. Turn that into vertex form. Have a great day. We'll see you guys next time.